Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows or console compilers. Today we will create a project to communicate with an LCD display. Today we're going to be doing something a little different. This is a crossover project with our custom PC hardware YouTube channel. Back in 2023, we created a series of two-line displays for our Odroid cluster. These displays make use of the Adafruit USB and serial RGB card, allowing it to be easily connected to a computer's USB port and controlled by software. Today we're going to be building upon that by using a 4-line and 20-character display. This video is going to specifically concentrate on the software we need to write to display information on this little LCD display. So let's have a look at our code. The code for this project can either be done in the Windows compiler or the console compiler. The principal task is to display disk capacity information on our small LCD display. So we have added two libraries to our application, the LCD display library and the drive information library. I'll cover both of those in a moment. As we're going to be communicating on one of the COM ports, we're going to create a global variable called hcom. This will be the handle for our LCD display COM port. As you can see, we have a camera set up to the LCD display so we can see what appears on it when we actually send messages. But first of all, we have to gather some information on our drives. We have a number of volumes on this computer, and the computer which is going to be hosting this LCD display also has a number of drives. So we'll need to gather information on each of these drive volumes. The amount of disk space that is free, the total size of the disk volume, and the percentage free, and to display this on our LCD screen. So first of all, we're going to gather some information using functions within our libraries. So we're going to create a number of local variables to hold the information we're going to send to this LCD display. First of all, we'll get the computer name using one of the functions in our drive info library. The PC computer name function will return the name of the current computer this application is running on. Next, we're going to open a COM port to our LCD display. There is a function called LCD open port within our LCD display library, and that's what we're going to call first. This function will only take one parameter, and that is the COM port on which we wish to communicate. To know which COM port is actually in use, you can press the Windows key and the letter X on your keyboard. This will give you a pop-up, and you can pick Device Manager from the list. On Device Manager, if we open up the ports, we can see that our USB serial device, in this case, is COM9. Depending on your computer, it may be a number other than this. If the return from this function is 0, it means we were unable to open the COM port, so we can exit the application immediately. So let's have a look at the LCD open port function and the library for our display. I'll put a link in the description below to the PDF file that gives the full description of all the commands this kind of display can actually take. At the top of our library, I've created a number of string constants. These will make it easier to control the display. The main display command is this hexadecimal value. It must be sent first, and following that we have a number of other parameters which tell the display what to do. For example, switch the display on or switch the display off. And we have a number set up specifically for setting the RGB colours on the display. So further down the code, we find the function which opens the port to our LCD display. We're using the COM open command. COM open is like opening a file on your hard disk. You first of all obtain the next file handle, using the free file function. Then using com_open with the parameter we've passed in this case com9, as that file handle. The error clear function can be used to determine whether an error has occurred or not. If the value is 0, then we have opened the port successfully. If the value is non-zero, then we have not opened the port. So if we have opened the port successfully, we can return the com handle. This com handle is used through the rest of the application to communicate with the LCD port we have opened. As you will see from the help file, the com_open command is quite straightforward. Normally in using your COM port, you would expect to use a com_set command to set parameters up, for example for the baud rate and the flow handling. However, since we're using a USB port, we don't have to do any of that for this particular display. It handles all that for you. So we just take the defaults. So now that we've established a link to our LCD display, we can now start to configure it. The Adafruit board has an EEPROM on it which it will store configuration information. So once you've set a colour, it will remember that the next time your system is powered on. I initially used this function to set the display up as a 4-row 20-character display. However, having used this function once, I don't need to run it again, as the Adafruit board will remember the setting. Next thing I want to do is to clear the display. So there's another function in our library we can use to quite easily clear the display, taking its single parameter, which is the handle of our COM connection. So in our clear display function, we're taking the single parameter, we're using the com_send command to send the display clear constant to that port. And again, we're testing air clear. If that returns 0, then the function has been successful. As you'll see from the rest of the functions, they all take the same approach. They all use the com_send to send the information to the port, and we then do an error test to make sure that no error has occurred. So now that we've cleared the display, what do we do next? Well, we can set the colour of the display. So in this case, we're going to stick with the light blue. Next, we can set the brightness of the display. And this is set between a value of 0 to 255. So we're going to set it to maximum brightness. And we'll also ramp up the contrast. These again are two functions in our library. These two commands have the same kind of format as before. We're using the display command plus the command value and the level using $. So for brightness, this level is 255, which is maximum brightness. So next, we'll want to put some information on our display, but we'll need to get the drive sizes first. So there are two very useful functions in our drive information library. One, get drive size, and the second, get drive space. As you'll see from this example, what we get back is the information for each of the drives. And this is expressed in gigabytes. Having got the information from all the drives, we then have to decide which drives we wish to report on. So we're going to use a drives variable, which will be a pipe-delimited list of drive names. We'll start with the C drive, and eventually this variable will have a list of drive letters. So we're going to use a for next loop in a function called driveinfo, which will return all the information from each of the drives and place it in this input variable. We can then call another function within our LCD display library to display this information on our display. So let's go and create the driveinfo function. So here is a skeleton of our new function taking its three parameters. The drives variable containing the list of drive letters, the drive size and the drive space variables containing the information for all our drives. So as I said, we're going to be using a for next loop. So we'll create some local variables to allow us to handle that. So we now have to populate each of these variables within our for next loop. So our for next loop is going to step through using the pipe character as a delimiter. Parse count will give us the number of drive letters in the incoming string. We can then use the parse command to pick up the drive letter. And we can again use the parse and trim commands to chop up the information that's coming in on the string, giving us the details of the drive size. The use of string handling commands is very powerful in all versions of BASIC, and PowerBasic in particular. So now that we have the drive size information, we need to determine the drive space available on the drive letter we're currently processing. And we're going to be doing exactly the same thing, only this time on the drive space variable. Next, we have to determine the percentage of free space on each of our drives. And in this case, we're only interested in whole numbers for the percentages. So we merely have to divide one by the other and multiply by 100. And store that in the %free long variable. Next, we can populate the output variable. This will be built up, so we're adding to what's already in the output. So for each iteration of the long R variable, we'll be adding to this string. So we'll have the drive letter and an equals, and then the string format of the %free, with the % following it. And as there will be room for only 2 reports on each line, we're using the mod command to work out odd or even lines. So if it's divisible by 2, we're adding on a carriage return line feed to the end of the output variable. And at the end of the function, we can then trim off the last carriage return line feed. So if we turn on a display and attempt to run our application now, and there is the information on our screen. The C drive has 84% free. So we'll now add some more drive letters to our list. And the application should step through each of these drive letters. The beauty of this display is that once the display has gained the information from your application, it will display that information until such times as we give it more commands to change what appears on the display. So if we run the application once more, we will get the information for each of the 6 drive volumes. So we have successfully created the first page, giving a summary of each of our 6 drives. Our next task is to display all the information from each of the drives in turn. So back once more to the code. So we're going to call another new function called display all information. And this is the one that will build up the information to send to our display. And following that, we can clear the display and close the port down. But as I want to leave the summary page on display until the next run of the application, we'll then call again the display info function to show this summary page. So let's now go and create the display all information function. This function is going to be very similar to the previous one, taking the same parameters and using the same type of variables. Again, it will be a for next loop, but the first task within the for next loop is to clear the display, and we will work out the value of each of these local variables exactly the same as we did in the previous function. The only difference is going to be how we output this to the screen. In this case, I'm going to be using all 4 lines of a display to display the information for the computer's drive. And having populated the output variable, we merely have to send this information to our LCD display. And I'm going to leave that on screen for 2 seconds. So if we display our small screen once more, which is still showing our summary, and we run the application once more. We can now see the individual information on screen for 2 seconds for each of the drive volumes, using up all 4 lines of our display, and once it reaches the end, it will go back to the summary. The application is now completed, but the display will hold that information until we send it more data. The idea is that this application will run periodically on a NAS computer, displaying information on the small LCD screen. So at any point in time, you can determine the amount of space free on each of the volumes by merely looking at the LCD display. So as you can see, using PowerBasic to send information to a USB-driven LCD display is very straightforward. With a few functions, you can display information quite happily. And this particular LCD display has the Adafruit backpack. And this has all the software installed on it to allow you to control the RGB colours quite happily. Hopefully you'll find these libraries and code useful in your applications, but that's it for today. Thank you for watching.